Right, second part of this one is sequences. It's just a list of numbers, yeah? 2, 4, 8, 16. And we guess what the next one is? Well, we're doubling, aren't we? So the next one's going to be 32. So that would be the answer to that. Now you have to write down a rule of what's going on with this. And the rule here is going to be we start with 2, and then we multiply by 2. Yeah, so we start with 2 and go times 2 times 2 times 2 times 2. So if we had another one of 3, 12, 48, and the 48 and the next one, yeah, so what are we doing? We're starting with 3, and then we're multiplying by 4. Yeah, we're multiplying by 4. So start with 3 times 4 is 12, times 4 is 48, and times 4 is 96, 192. Okay, so you'll get a series of numbers, a sequence of numbers. You either have to work out what the next number is, and work out the rule of what's going on. And these are all of these. They were multiplying. When you have a sequence that times something or other, yeah, 3 or 4 or something, it's called a geometric sequence when you multiply. So you could have 8, 80, 800, 8,000. This is a geometric sequence because we start with 8 and we multiply by 10 every time. A geometric sequence. Now there are other kinds of sequences, and this one, Fibonacci sequence. He was a 15th century Italian mathematician who came up with this idea, and it's like this. You add 2 terms to get the next number in the sequence. What does that look like? Well, let's start with 1 and 2. So we add these 2 together to get 3. Then we add 2 and 3 to get 5. We add 3 and 5 to get 8. And we add 5 and 8 to get 13. And 8 and 13 make 21. A Fibonacci sequence. Add the 2 terms to get the next. Add the 2 terms to get the next. Add the 2 terms to get the next. And so on and so forth. Doesn't have to start with 1. You can have 4 and 4. Yeah, add the 2, you get 8. 4 and 8 make 12. 8 and 12 make 20. 12 and 20 are 32. Another Fibonacci sequence. Now the most important part of this sequence things are arithmetic sequences. Now this is not Fibonacci where we're adding 2 to get the next. It's not a geometric where we're multiplying something all the time. An arithmetic, we add the same thing. Every time. So an example of arithmetic one would be 4, 9, 14. And you see what I'm doing? I'm starting with 4. Start with 4. And I'm adding 5. So this is 19, 24, 29, etc., etc. So this is an arithmetic sequence. You add the same thing every time. Now, with arithmetic sequences, there is something else that we have to learn how to do. Now, you may have heard me mention the term. Now, as in algebra, when you've got, 2x plus 3y plus 4 or something, these are all terms, the individual parts within the expression here. And these are terms as well, because they're the individual numbers within the sequence. So we can number the terms, and the term is referred to as the n number, the n. So 1, 2, 3, 4, 5, 6. So this becomes the term, which we'll call the n. Now, what we have to do in this case is we have to find a rule, not start with 4, add 5, but we would have to find a little algebra expression so that we can work out any term, any number in the sequence for any term. So if we had the 100th term, we know that we've got to add 5 each time, but it would take far too long to go add 5, add 5, add 5, add 5 to find out what the number in the sequence is for the 100th term. So this is the way we do it, and it will, first of all, it will say find the nth term. Find the nth term, and then it will say find the 100th term. So these are the two skills that we need to be able to do. Now, first of all, what we do with these series of numbers is label up the terms above, as we have done, then find the gap between all of these numbers. Now find the gap, which is 5. So the gap is 5. I won't write it there. Yeah, we've got 5. Add 5, add 5, add 5, add 5, add 5. So the first part of our answer, in order to find the nth term, is that number 5 is attached to the n. It becomes 5n. If there was a gap of 3, it would be 3n, but a gap of 5 is 5n. So we've got 5n. Now we need to find out what 5 times n is. And here's the n, the red number at the top. So 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20, and so on, 25 and 30. Right, now the green numbers here, the value of 5n, do not match the original numbers in the sequence. So what we have to do is subtract one from the other. So 4 minus 5 is minus 1. 9 minus 10 minus 1, and you'll find that they all come out to be minus 1. Now, we put the two together, so we go 5n minus 1 is our nth term expression, and this is how we find any number. So let's just prove it for, say, the 5th term. So we do 5 times 5 minus 1. 5 5s are 25, minus 1 is 24. That's the number in our sequence. So for the 100th term, we're going to do 5 times 100 minus 1. So that will be 500 minus 1, which will be 499. So you can find the term, the value of the number in the sequence for any term you like, once you worked out this expression for the nth term. So let's do another one now. 5, 8, 11, and 14. There you go. So first of all, let's label up the nth terms, which is 1, 2, 3, 4. Find the gap. 3, 3, 3. So the gap becomes 3n. So 3 times 1, which is the n number, is 3. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Now they're not the same, they never are. Now we subtract. 5 take away 3 is 2, 2, 2, 2. It's a positive 2. So we combine the two together to be 3n plus 2. And if we want to find the 10th term, 3 times 10 plus 2, which is 32. Okay, let's do another one. These are good, these. I like these. 2, 5, 8, 11, and 14. So, label up the terms. 1, 2, 3, 4, 5. Find the gap, which is 3, 3, 3, 3. So 3 becomes 3n. So 3 times 1 is 3. 3 times 2 is 4. 3 times 2 is 6. No, yeah. 3 times 3 is 9. And 3 times 4 is 12. Then 15. So then we subtract. 2 take away 3 is minus 1. Minus 1, minus 1, minus 1, minus 1. Therefore, combine the two. 3n minus 1 is the nth term. If we want to find the 20th number in the sequence, we just go 3 times 20 minus 1, which is 59. Yeah? Good. I don't know whether we've got another one to do. Sequence. Yeah, let's do one more for this part of the. That's quite an involved lesson. Let's go. 2, 9, 16, 23. Okay. Label up the terms. 1, 2, 3, 4. Okay, the difference is 7, 7, 7. So 7n. 7 times 1 is 7. 7 times 2 is 14. 21, 28. Subtract 2 minus 7 minus 5. Minus 5. Minus 5. Minus 5. So there, our nth term is going to be the combination of these two, which is 7n minus 5. Okay, that was that. Now, we did a little bit extra, didn't we? We did the difference between an expression, which is just like one of these, 3n minus 1. Doesn't equal anything, it's just a statement. That's an expression. And then we had an equation. And the equation is 3x plus 1 equals 10, something like this. Yeah, so an equation equals something, and normally in an equation we are asked to solve for x, find out what the value of x is. You can have a formula, and a formula is pi r squared equals a. Now a formula is used to find something out, yeah, where you substitute these letters for numbers, you work all that stuff out, and then you'll have your answer what a is equal to. This one is actually to find the area of a circle. And then you have something called an identity. We'll look at how to work out identities later on. This is not a proper identity. Plus b plus a. Now the way to identify an identity, it has a triple line in the middle, and we go, I don't know, 2x plus 4 plus a, something like that. It doesn't matter what this is, either side, but the way to pick it out is the one with the 3 lines. And an identity is a little bit different from an equation, because here we're finding the value of x in order to satisfy that the left hand side equals the right hand side, and here, regardless of what the value of x is, it will always be equal to each other. So if x was 1, the left would be the same as the right. If x was 99, the left would be the same as the right. That's the difference between an identity and an equation, easily spotted with the 3 lines. Okay, so that's stop there.